Processes and jobs. Before we get into this lesson, I want you to understand what exactly each term means in Linux environment. Well, first we have applications, which are also referred to as service. An application or a service is like a program that runs in your computer. And then application could be anything like in Windows, you have Microsoft Word, PowerPoint. In Linux, you have programs or applications like NTP, NFS, Apache, and a whole bunch of different programs. So that is an application and service that runs on your computer. Then you have a script. What exactly a script is? A script is something that is written in a file and then packaged it in a way that it will execute. So any application that is running in your computer, for example, Apache, you would have to run that as a script, and that will run in the background. So that's actually a script. And also all those different commands that we run in our Linux environment, all of them are also referred to as scripts. Then we have a process. What is a process? When you run an application or when you start up an application, it actually generates process with this process ID. Now processes could be one associated to that application, or it could be multiple processes. Then we have daemon. The daemon is, I could tell you when I compare it with a process, is something that continuously runs in the background, or it doesn't stops. So when you run a daemon, which is also a process, but it keeps on running in the background and it keeps listening to the incoming traffic or outgoing traffic. Then there is a thread or threads. Every process could have multiple threads associated with it. An application that is running in your background, let's say NFS, when you run that application in your Linux machine, it could have many multiple threads. If a remote machine tried to connect to you through NFS, it will generate one thread for it, and it will generate a second thread or third thread for other computers that are attaching to it. Then we have a job. A job is something that is created by a scheduler, like a work order, to run those applications and services. In process and service commands, we have a first command is systemctl. This command is now used in Red Hat 7 and it is being replaced. The old command that was running an earlier version of Red Hat or CentOS is service. Service is now being replaced with the newer command systemctl. Then we have a ps command. This command allows you to see what are the processes running in your Linux system. You could use different options with that to find out exactly the process that you are looking for. Then you have a top command. Now when you run the top command, you will see all your processes running in your system depending on which process you want to see first based on its load. And it also tells you your memory information, CPU information that is being used by that process. Then we have a kill command. The kill command kills the process. It kills by the process name or kills by the process ID. So when you start an application, again going back to our example of Apache, when you run an application HTTP, which is associated with Apache, it has a process ID to it. You could stop that process by running systemctl stop httpd, or you could simply kill followed by the process name or process ID. We'll cover kill command later in this lesson. Then we have cron tab. Cron tab command is used to schedule these applications or these processes or these services for you in your system. You run cron tab with -e to edit it, and there are different options that we'll cover with the cron tab. So when that process or application is scheduled in cron tab, that becomes a job. And the last command that we'll cover is at. At command is just like cron tab. The only difference between at and cron tab is at is scheduled as one-time basis or as an ad hoc process. We'll look into our Linux machine and we'll go over the processes and some of those commands. Let's log in. Clear our screen, cd, check where we are, who we are, and what is the host name. Good. So do clear. All these commands that we will be running, most of these commands need root privileges. So we could either become root on this terminal, or we could use a PuTTY terminal, whichever the terminal that you prefer. For this, we will stay on the console, so become root. Okay, let's clear this out. Now system CTL is the command to start an application or stop an application. It also is the command that is used to list, or sorry, to enable an application to start or stop at the boot time, meaning every time your computer starts up, you need certain applications to run. So to start an application, let's say I wanted to start an application called NTP. NTP is a daemon that runs all the time, which stands for Network Time Protocol, which syncs your time to other clocks. So systemctl restart NTPD. The D we are putting in because it's telling it it's a daemon. You hit enter and you get your prompt back. The reason you get your prompt back is because it did started that NTP service. Now how do we check if that service is running? You do PS, and the option that I use, my favorite, is hyphen or dash EF. You could use other options. PS minus EF, you hit enter. When you hit enter, you're gonna see all bunch of processes that are running in your system. Do you really want to look into all these processes? No, you are looking for only one process which you just started. So you do PS minus EF, pipe it, grep it, NTPD, and it will tell you yes, the process is running or the application is running. That's right here. You could also use the same command, systemctl status command, to view if the process is running. There it tells you right here the Network Time Protocol, that's a service, and it's loaded and it's active and it's running. And it's running since the time, and it gives you a lot of other details. Now what if you wanted to stop this process? You could do system ctl stop NTPD, and it stopped. See if it still exists. PS minus EF grep NTPD. It does not exist. If it does not exist, then why we are getting this line? Well, if you pay very close attention, this is telling you that the command that you just ran, PS minus EF, when you run this, the Linux system, the operating system, is so fast and so sharp that it gets you the same command that you're running. You see, it's giving you this grep, that I ran this grep, and this grep is also considered as a process itself, within itself. So that's why it's giving you. You're always gonna get this grep whenever you run this grep command. So this is about PS systemctl command, and if you wanted to enable an application, you could just run systemctl enable NTPD, and this will enable. See, it says created symbolic link. It is created symbolic link in the etc configuration file. So now every time my computer, my Linux machine is gonna start, it will start the NTP daemon with it. Another example of different process is sendmail or rsyslog. Let's see, rsyslog is another application or process that runs which collects your logs. So let's see if it's running. Yes, you see it is running. And if you wanted to check the status, we could also do systemctl status rsyslog, and it will tell you this active and it is running. So that's how you find out about all the processes. Now what if you want to kill that process? Sorry, let's take one step back and we'll run top command. Top command is one of the favorite command for many system administrators because this will tell you about the system resources. Also, one of the favorite question by an interviewer who is going to interview you. They will ask you, tell me about how do you monitor the system. This is where you could tell them. You run the top command, and the top command will give you there are total number of total tasks 170, one is running, 169 is sleeping. What are the CPU usage? Is it too high? Is it too low? What is the memory usage? What is the swap space? And then right here it is listing every process that is running in our Linux environment with the process ID, who the user is, and what is the memory being used, what is the CPU being used, how long is it running for, and what is the command associated with that process. So this has so much information that I cannot cover in this lecture. So what I will encourage you to do is do man on it or read a lot more about it in different documentation. I will also include some documentation that will explain top command in detail. You could also feel free to Google it. You could view top, but you should spend some time, quite a bit time, to look into the output of this command. Now what if you wanted to get out of it? Just simply type Q. Once you type Q, you will get your prompt back. Now we'll go to the command kill. If you remember, we use ps-ef to check which processes are running. grep, and I wanted to do ntpd. So ntp is not running. Let's start it first. So we'll do system ctl restart or start, doesn't matter, ntpd. It has started. Let's check again. ps-ef grep ntpd. It is running. Now I wanted to kill this process. There are two ways to do it. One is if you do systemctl and do stop this command, or you could simply do kill. Kill will kill the process regardless of whether it's going to go down gracefully or not. So which process we're going to kill? Right here, this is the process ID. So kill simply 12027, the process ID. Hit enter. Now let's verify if it killed it. Yes, see, it's gone because we are killing the process ID. The same way, whichever process that you have, you could just do kill ps-ef and then do more because you want to see all the processes. There are tons of processes that are running in your system. Any process that is hung, you could kill it. And how do you know it is hung? You could type top command and you will see here under memory or CPU if any of the process is using, let's say, 99% of CPU or 99% of memory. That's definitely one of your candidates to use the kill command to kill it, to free up the resources. System administrators use this command many times to keep their system up and running and healthy. Next we will learn cron tab. Let's exit out and we will become ourselves. Cron tab allows you to schedule our scripts or
our commands whichever way you want to schedule. So let's say I wanted to schedule to create a file that has some kind of output at a certain time. First, let's check the date. My date is Tuesday, March 13, 12:19. This clock is 1 hour off. I wanted to set this clock first, so become root to set this clock. And I'll do date minus S to set. And it will be, I think I have it set here. Yes, it will be 13 March 2018. The hour, time, the second, and hit enter, and then you do date and it sets the correct date. Now let's go back to our self. Who am I? And we are ourself. Clear the screen. Now let's do cron tab. Cron tab is a command itself. You have to do cron tab minus E to edit the cron tab and specify whatever that you are trying to schedule. You hit enter. Once you run cron tab minus E, it will bring you to a VI editor mode, the same way as if you run VI followed by the file name. So you are in there, hit I to insert. The first one is the minute, so we want to schedule something at 22. Second one, hour, 13. Then the day of the month, I'll put every day, which is asterisk. Month is 3, which is March. Day of the week, I'll do every day. Okay, so we schedule the time. Now what do we want to do? We want to do echo. This is my first cron tab entry, and I wanted to put that to a file, cron tab dash file, or cron tab entry. So if you notice, the time has quickly changed. It already become 1:22, so I'm just going to change it to 23. Hit escape, right quit, and hit enter. Now the time is 21. I still have 43. So let me just do quickly 2, so this way we don't lose time. So date 53. Let's say, do we have the file created yet? Not yet. This is the first one. I had it before. That's fine. Date 22. Perfect. So let's see, did it create it? There you go, my first file. Sorry, not my first file. ls-ltr. It will cron tab entry, because we are doing cron tab minus L. It created cron tab entry, and the cron tab entry is cat cron tab minus entry. This is my first cron tab. So it did create it, but it created itself. So I schedule it, that's why it created it. To do a quick comparison of our commands that we learned with our Windows environment, is the first one, systemctl. When you're in your Windows environment, right click on your Start Task Manager. You see all these applications. These are the applications you could stop and start using the systemctl in Linux. These are the processes that run, that associated with all those processes, and many of them are daemon processes like service host process for Windows. Many of these run as the process. These are the services that you could shut down with systemctl. And the performance, remember we ran the top command. The top command tells you about your CPU, your memory. Exactly, this is what you're looking at with the Windows Task Manager. This one gives you the network usage and of course the user itself. So this is a quick comparison between Windows and Linux, and I hope you run all these commands one by one to learn more about them.